So here I have f of x equals x cubed plus 12x squared plus 5, and I want to find all of the following information: critical numbers, inflection points, relative max and min, where the function is increasing, decreasing, and where it's concave up and down. So I'm asked about first and second derivative information all at once, and you might even recognize this function from section 4.1 where we just knew how to find first derivative information. So I'm going to do the same two steps for both derivatives and get two different types of information depending upon which derivative I'm looking at. So I'm going to start with the first derivative information, fill that all out, and then I'll move on to looking at the second derivative. And I'm going to keep all of my first derivative information to the left side. And then on the right, I'll do the same two steps with the second derivative. So my first step is always taking the derivative, which is going to be 3x squared. 12 times 2 is going to be 24x. And the derivative of 5 is 0. So I'm going to take my first derivative, set it equal to 0, since that's my first step. And I'm going to factor this. I factored this before. It's a greatest common factor of 3x times x is 3x squared. And 3x times 8 is 24. So I'm just trying to figure out what makes the first derivative 0. Well, to make 3x 0, x would have to be 0. And to make x plus 8 0, x would have to be -8. So, since these make the first derivative 0, these are my critical numbers. Critical numbers, all that they have to do is make the first derivative 0, and order doesn't matter with these. I just wrote -8, 0, because that's from least to greatest. So I have my critical numbers. Those are the only places where relative max and min can occur. And those are the only numbers included on my intervals for increasing and decreasing. So my second step is to use these numbers in making a sign chart. So I'm going to label on here my two critical numbers. So my first critical number is at -8, and my second critical number is at 0. And so I could test any number before -8. Maybe I'll just plug in -10. And I'm going to label this number because it's important. -8 is my critical number, so I'm going to write f prime equals 0 there. And then we're always plugging into a derivative on our sign chart. So if I want to find increasing and decreasing, I'm looking at plugging into the sign of the first derivative will tell me whether it's increasing or decreasing. So I'm going to plug into my first derivative. 3 times -10 is a negative number. And then -10 plus 8 is also going to be a negative number. So this whole interval is going to be a negative times a negative, which is going to be positive. So we're increasing at first. Looking at the sign of the first derivative, I'm going to plug in any number between -8 and 0. I'm going to plug in -5. So 3 times -5 is a negative, and -5 plus 8 is a positive. So negative times a positive is going to be negative. So I went from increasing and now I am decreasing on this whole interval. So my first critical number is a relative extrema because I have a sign change. And to go from increasing to decreasing, this must be a relative max. So I can even pop down here and my relative max point is going to be at -8. To find the y value, I'm going to hold off on that. I'm going to keep looking at the derivative, but I know it happens at -8. So I'll find that y value in a minute by plugging into the function. I'm going to finish working on my sign chart. Now I'm going to choose any number after 0. Maybe I'll plug in a +10. And I'm always plugging into the derivative on a sign chart. And I'm going from 0 on. I'm going to label my derivative in here. Critical number, and I plug in 10. 3 times 10 is a positive, and 10 plus 8 is also positive. So a positive times a positive, we're going to end up switching to being increasing here. I have a positive first derivative. So at 0, my critical number, my special number where I can have a relative max or min, I went from decreasing to increasing, which means I got a relative min. And I can go down and try to fill that out on these answer spots here. I have a relative minimum at 0. So now it's time to fill out all the information I have from the first derivative. So I plugged in my critical numbers already, filled in that blank. My relative max and min, I need to find the y values of these points. So sign charts, you're always plugging into a derivative. And to find y values, though, we're always plugging back into the original function. So I need to grab my calculator and do negative 8 cubed plus 12 times negative 8 squared plus 5. Just make sure you do those exponents before you multiply. And you should get a y value of 261. There's my relative max. The only time we plug into the function are for these y values. My relative min, I'm going to plug back into the function as well. My critical number, I plug in 0, and this one's easy to plug in. I probably don't even need my calculator. This one is 5. 0 cubed plus 12 times 0 is all 0, plus 5 is 5. Anything else from the first derivative I want to fill out now? Increasing and decreasing, that is first derivative information. So increasing is wherever the first derivative was positive. And remember, we should only have infinities and our critical numbers here. So from negative infinity to negative 8s, I have a positive first derivative, which means I'm increasing. Union, I have from 0 to infinity. So just be super careful. Don't accidentally put like 10 to infinity. That was our random test value. Only critical numbers and infinities are in these answers. Same thing with decreasing. I want to be a negative first derivative, and that happens between my two critical numbers, negative 8 and 0. Everything else I have left, inflection points and concavity, that is all second derivative information. So I'm going to do these same exact 2 steps, taking the derivative and making it 0, and then making a sign chart. But I'm going to do it with the second derivative now, and it'll give me completely different information. So to find the second derivative, I'm going to take the derivative of the first derivative, and it's easier to do it in this not factored form. That way I don't have to use a product rule. So I'm going to take the derivative of 3x squared, bring down my power. I have 3 times 2 is 6x, and derivative of 24x is just 24. This is much easier to set equal to 0 because I just have a linear function. I have an mx plus b here, which just means I don't have to factor. So I'm just going to subtract 24 from both sides. I have 6x equals negative 24. And then I can just divide both sides by 6. And get x equals negative 24 divided by 6 is going to be a negative 4. So much easier to solve the second derivative. And now this is my possible point of inflection. And again, I say possible because points of inflections need to have the second derivative be 0. And they also need to be where the concavity changes. So right off the bat, I went in and I put these critical numbers down in my solution spot here because critical numbers only have to make the first derivative 0 undefined. Now that I'm looking at inflection points, I don't know if this is an inflection point until I see that concavity changes. So far, I don't really have any answers to fill out. I'm going to move on to my second step, which is to make a sign chart. So I have my sign chart here, my important number that's included on the intervals about concavity, and this is my possible point of inflection. Negative 4 is special because it makes f double prime 0. So I can test any number to the left of negative 4. Maybe you want to plug in negative 5. I'm going to plug in negative 10. And I'm always plugging into the derivative for these sign charts. And since I want concavity, I need the sign of the second derivative. So I'm going to plug into the second derivative to see what kind of concavity I have. So I have 6 times negative 10, which is negative 60, plus 24. Negative 60 plus 24, that's going to be some negative number. 24 and you take away 60, you're definitely in a negative number. So I have a negative piece here. So I'm concave down before negative 4. And then after negative 4, I can plug in anything. This is my favorite interval because I can just plug in 0. If I plug in 0 into the second derivative, will tell me concavity. So 6 times 0 is 0 plus 24. Well, that's 24, so it's positive. So I switch from being concave down. And I switch and I'm now concave up. So, do I have a point of inflection? Well, yes. This is where I switched concavity from concave down to concave up. So I do have a point of inflection because it made the second derivative 0 and changed concavity. My point of inflection is at negative 4. But since it's a point, just like the relative min and max points, I need to find the y value of the point by plugging into the original function. The only time you have to plug into the original function is to find our y values. So to find the y value of this point, I'm going to grab my calculator, do -4 cubed plus 12 times -4 squared plus 5. The y value of my point is 133. And then the other piece of information for my second derivative is concave up. We're concave up from -4 to infinity. And remember, only use your possible point of inflection in here, not your random test values. And we're concave down before -4. So negative infinity to -4. Now we just found all of the information from one function.